Hello all, welcome in Failte Solar Training Academy. My name is Rafał, I'm the head of technical department in Failte Solar. Today I would like to continue on SOFAR Solar PowerAll unit. We're going to show you how simple it is to connect the unit, inverter and battery, okay? How fast, how simple it is, and I would like to tell you more about that unit. We're gonna use one inverter and one battery. Inverter is 5 kilowatts on the output. One battery is 5.12 kilowatt hours of storage. A great thing about that unit is you can put up to 6 batteries under one inverter. That's gonna give you 30 kilowatt hours of storage on one inverter. Not only that, they can be connected in master-slave, okay, scheme. That means first inverter will be master will be controlling the rest of the stack and the banks. So if you want to optimize up to six inverters, that's gonna give you 30 kilowatt hour storage on single phase and up to 180 kilowatt storage. This will give the customers opportunity to go off the grid completely. Few words from SOFAR Solar catalog that is available from our sales department. Today we got 5 kilowatt inverter, 5 kilowatts of storage. This unit is IP65 rated, so you can put it actually outside, but as always, manufacturers recommend you actually can't put any inverters in direct weather conditions, so some kind of a cover on top is needed when you want to mount that outside. Ambient temperatures range is from the -10 to +50. One battery with one inverter weight is 74.5 kg, so you need to have someone else to carry those batteries because each battery only is around 50 kg. So battery rated voltage, this is the high voltage. So it operates at 400 volts. Max charge and discharge current of the high voltage batteries, BTS, it's 20 amps. On the MPPT side or the PV input side, manufacturer states that the rated input power for PowerAll on one MPPT is 360 volts. MPPT operating voltage is between 520 down to 85 volts, okay? There is 2 MPPTs. Current from the panels max is 16 amps. The maximum efficiency of that solar inverter is 97.8%, which is magnificent. European efficiency of the solar inverter is 97.1. Topology of that system is that it's transformless, okay, like 99% of the inverters sold currently. Battery type is the LFP. And that's it about the unit itself. If you got more questions, call us, ask our sales, or ring our technical department directly, and we're going to give you more insightful information about the unit, okay? Okay, so carry on. We're going to start to do the wiring. So we're going to start with communication wire. To expose the RJ45, you need to open that cap first, okay? Then you need to reverse the cap to expose the RJ45, okay? There is a special slot inside, okay? So you need to push the lock pin down when installed and just start pushing that towards the terminal. While you're doing that on the inverter, I advise you to push the wire along the way, okay? So into RJ45 need to go into the slot, then we're gonna start to close the outer rings, okay? While you're closing that one, you need to push the wire as well, okay? This is to get proper connection between the pins here. So we're gonna start with interlocking and securing the components between each other. And now we got inverter and the battery secured together. Now we're gonna do the mounting bracket. Assuming you got the bracket fixed to the ground, okay, interlocking fixed, we can start from doing that communication cable. Okay, so remember, you need to expose RJ45. If you're using battery input 1, you need to use COM input 1 as well. Okay, this is group 1, this is group 2. So we're gonna start with group 1. So now we're gonna run the communication. I'm gonna start at the inverter. So first I put the terminal firmly in. While I'm pushing the wire, I'm hiding the pin to go inside the outer shell. Okay, first thing, I'm still pushing the wire, I'm securing the connection, which is the big outer ring. Okay, when that's firmly done, I can close the IP65 outer ring. When that's done, COM1 on the inverter go into link port in. Same situation here, you need to unscrew the small outer ring to reverse and expose the RJ45. So again, pushing down the wire, we need to secure the outer ring. Pin is in, washers touching the port. So now we can start to secure the unit. While still pushing, you need to close the IP outer ring. And now you got the communication wire between the inverter and the battery ready. Another very important part is the communication and resistor. Okay, it's a must and necessary to close the last battery with resistor like that. By doing so, you're closing the loop of communication. Okay, so make sure it's in the last battery on the link port out. Gonna fit it first. I heard the click, good sign. Now I'm gonna secure it, and it's fitted. So next thing, we're gonna connect the power between the inverter and the battery. We need to remove the caps from the terminals, and we're gonna start with negative terminal. Okay, you need to hear that click. Okay, sometimes it's need a bit of power, so you need to be gentle but firm, like that. So here should be one line visible, and on the top there should be one line visible when you're looking from the side. Okay, and now positive terminal. Just checking, one line here, one line here, that is correctly. Now we're gonna tidy the wires. Okay, dedicated slot is here for the power and for the communication. So now we got power and communication, including an resistor, and at that stage you will be able to power up the unit. Okay guys, so this is the basic steps. Okay, I just want to show you how to wake up the system. Before you do any wiring, you can prepare for the commissioning. Okay, so this is that. Battery power isolator on, activation, battery activation button, one beep, that means the battery is on. Now we need to wait around 20 seconds and the unit is waking up. Okay guys, so we powered up the inverter only on the battery. Okay, you can do basic configuration of the unit only on the battery while your electrician is doing the AC side. That's why we got the alarm, and we're gonna start from basic settings of the inverter. Okay, later I'm gonna connect the AC sides to show you that the fault isn't there anymore, but as we speak now, basic configuration. Set the language, my case English, set the time. Safety parameters, safety regulations. We need 039, okay, that's Ireland, and we got Ireland, and we got EN 50549/1. This is for the ESB and SCAI. Then energy storage mode. For now we're gonna use it in self-use mode. So that option, okay, is for the purpose that you need to wake up all the channels, okay. On that firmware that's on the unit, you need to do it manually. You can obtain the new firmware from me, and that firmware will have automated input channel configuration. In my case, I got battery input 1, so we need to set the battery input 1. That will wake up that input, okay. We got 2 MPPTs, so PV1 and PV2 need to be enabled as well, okay. So battery 1, we don't have any battery on the channel 2, so not in use. Channel 3 will be PV1, channel 4 is PV2. Next thing is the EPS mode, okay. It's emergency power supply. So if you got emergency backup fitted, then enable that. If you don't have that, just disable. Then you set the communication. It's preset, should be 01. So always check that, it's 01 by default. Baud rate 9600, and we got 9600. Second thing is to enable and disable all additional things that corresponding to different countries. I'm gonna show you what should be enabled and disabled in Ireland, okay, on all PowerAlls. So we need to go to advanced settings. Engineering code is 0715 and enter. And we're gonna start with advanced settings. So first thing you're gonna see is the battery parameters. Battery number, we got only one battery, so in group 1 just take the one battery. If it's 2 batteries, the system will detect lack of one battery and it will produce alarms. So we got one battery. Group 2 is 0. Now the battery parameters in group 1, dip of discharge, standard settings will be 80, 80, 20. These second settings are for the reason that you want actually to keep the battery healthy, so and allocate in case of EPS, you can set that to 50%. And then the battery will only work 50 to 100%. In case of EPS, battery will only, in that case, utilize the other 50%. Save, and we come back and check the settings. So guys, you can probably gonna see different settings. Usually by default it's 80, 80, 20. So the battery will drain until 80%. EPS discharge depth will go down to 20%. Safety buffer of the EPS, it's 20%. So I advise you always to leave that 20% in the battery in case of any power losses in the grid. Of course, you can set it up to 50%. Then the battery only gonna work between 50 and 100 to support house loads. Now we need to go back. This is very important part. Battery auto active. Battery auto active control means if there was loss of grid for a certain amount of days, battery drained to 0, that option gonna recharge the battery. It's called blackout start, okay. That inverter will always know when the battery gonna hit 7% SOC, Auto active control gonna recharge that battery down to 20% using first available power source, either AC or DC. So always enable that function. Feed-in limitations, if you have any, you need to enable that and set the inverter to correct parameters, otherwise disable. Power curve scan. Along the year, that option gonna give you around 5% more yield, up to 5% yield from the array, okay? So we can enable that. That's very important. Logic interface, this is demand response mode, only used at the moment in Australia and UK. We don't have that, we don't use that option, so we need to disable that, okay? So DRM0 needs to be set to disabled and DRMN need to be set to disable as well. Number 6 is the factory reset. Number 7 is parallel settings. By default they are disabled. Number 8 is the option to reset the Bluetooth if you lost communication with the app. Option number 9, CT calibration. That option is used if you use third-party CT clamps. Always recommend to use only original ones, okay? Because there is different ratings on the CTs, and that option may not need to be calibrated every week, depends on the CT reading. If you see any offset, then it's good to run through the CT calibration. If you need to use electricity meter, you need to enable that, okay? Great thing about PowerAll, it got direct CT connection on the multi-port terminal, so we don't need that meter, okay? We have direct connection to the CT. That was proved to work up to 100 meters. So disable the meter. Neutral port grounding. Enable that if your equipment that you connecting to the unit on the backup needs the bond between neutral and the ground, so you need to enable that. If you're using any common appliances, that can be disabled. Under that, we're gonna have the energy statistics, system informations. That's very nice part of the firmware. You got each individual items within the inverter separated, and those informations are for your own interest, so you can check do we have any new firmware. If we do, you can go and check the firmware actually on the unit. You're gonna find your SN, and this is the basic informations about the inverter. You need to go to the second screen and we need to press enter. If it's gonna ask you for the password, it's also 0715. If not, you can actually see the firmware version. We can check the battery info. Automatically all the informations are present here. Safety parameters, this is the section where if you got auditors from SCAA, they want to see all the parameters corresponding to NC6. Those batteries are very interesting. Each battery in the stack can work independently. That's why it has its own PCU built-in and also BMS. So we can check the PCU versions. I always ask about that. This is very stable version 114, BMS 112. That's fine, they can be mixed, that's no issue. So this is the system informations. Event list, if you got any alarm, event list part will show you actually what it's about. I don't have the AC side connected, that's why unit detecting that there is no grid. This section is dedicated, there is a separate video how to perform software update. So my advice is after basic commissioning, I can send you latest updates for the unit and for the batteries. That operation only takes 10 minutes. I advise you to do it after each and every installation to bring the unit on the latest firmwares. And you also have the battery real-time info. All the batteries comes charged between 50 and 60%, so that one is at 55% SOC. Battery state of health is at 100%. Battery temperature is 15 degrees, okay. Battery cycles, 0 cycles because it's a new battery. Then power control, low voltage, okay, of the battery cells actually, 52.6, okay, that is the high voltage, around 400. PCU state normal, internal temperature is at 31 degrees and radiator temperature is at 19. So now I'm gonna fix the fault, okay, and I'm gonna show you how the unit is operating with the basic settings like that. So this is the AC grid side, okay, very simple. All the ferrules come with the unit, so that was crimped. Live, neutral, PE, all connected. For that video and training purposes, I got the wires exposed, okay, that I put the CT on it, and I just want to show you the basic operation of the unit. This is the multi-port communication. As you see, you're gonna only use 2 pins, which are for the CT, 1819, CT plus, CT minus. Ferrules included, so make sure you crimp them, okay? This is that part for the EPS, emergency power supply. Remember, you can have full output of 5 kilowatts when you're using 2 batteries through the EPS. That's why the cables are exposed, just to show you where to connect them. They are clearly marked on the terminal, PE, live and neutral. So AC side were connected, okay. Unit is counting down to 60%. It's doing the basic checkups of the system check. As you see, alarm is gone on the display, also on the event list. The battery is in standby because it's not doing nothing. I have that EPS backup installed, okay. We can see basic informations, which is the grid voltage. AC power will be visible, grid frequency at 50.03, 50.01. So first thing, if we want to use the backup, we're gonna go and enable the EPS mode. We've put the unit into the EPS mode. We still have the grid, so the system doesn't log in any faults. Now we're gonna connect load to EPS. EPS is always active because it's in parallel with the grid, but when you're gonna lose the grid, the EPS gonna use the batteries to cover the load. To show you the basic operation, okay, I got load, which is the heater fan, connected to the EPS. That's 2 kilowatt load, okay. It got different steps, so I'm gonna show you step 1, step 2, step 3, and how that corresponding to the informations fed by the inverter. Okay guys, so now we're gonna mimic loss of grid on the inverter, okay. Gonna check the grid. We got the grid, okay. The heater is on. The heater should now take power only from the batteries. 2 kilowatt load on that side. Battery feeling that it's not using the grid. You can see discharge sometimes to the grid around 10 watts, but that's only for a few milliseconds, okay. Just to fight against the grid if the grid wants to bring power to our load that is supported at the moment only with the battery power. Assuming we got the grid loss, okay, our load working at full output. Now the unit's supposed to go into the EPS mode. So I'm gonna show you how the EPS is working. Okay, the unit is now in self-use mode. That means it's a fully automated system. In that self-use mode, the priorities is the load and then battery. Okay, if it's got anything in the battery, it's gonna keep supporting the load. Okay, in case if the battery gonna go low, then it's gonna use the grid as well. Let's start our heater fan. You can see some discharge. That discharge is only last for a few milliseconds. It's basically inverter fighting the grid because it doesn't want to use the grid. Okay, so it needs to send a bit of power to fight this off, and now as you can see, batteries support full grid. Now we're gonna mimic grid lost. Okay, blackout. Blackout in 3, 2, 1. Straight away, no interruptions. Okay, we can see that the unit is in EPS state. You're gonna see the alarm because that alarm indicating that the grid was lost, so that's normal, and this is the EPS state. So the unit was now at the moment synchronized. Okay, so we got 227.3 volts and 50 hertz sending to our load. Now we're gonna show you when the unit come back on grid. Grid is now back. Units need around minute to switch back to the grid. As you see, it's detected the grid, so light is off, but the relay is now gonna come back to grid connection as well. Now our load is off and system now waiting to provide energy again. And that's it, guys. Okay, guys, so this was the intro for SOFAR Solar PowerAll with single battery. As you can see, commissioning, setup, connections, commissioning won't take longer than 1 hour if you are there with 2 people. So guys, please, if you need more info on the operational parts of the SOFAR Solar PowerAll, contact our technical department if you are a current user and installer of PowerAlls. If you got questions about the pricing, our lines are always open 9 to 5. So please send us email. Just basically contact us and you're gonna get proper support. Thank you very much for today. See you next time.